Welcome to day 20 of our STL course. Today we embark on a key topic in the STL ecosystem, iterators. These are the foundation of container traversal and a gateway to using STL algorithms effectively. In this session, we will dive into what iterators are, explore their different types like reverse iterators and const iterators, and even write a basic custom iterator. By the end of this lesson, you will not only understand how to navigate STL containers in multiple directions, but also how to do so safely and efficiently using iterator best practices. Let's get started. Let's take a look at today's learning objectives. By the end of this session, you will clearly understand what iterators are and why they are used in STL. You will learn how to use reverse and const iterators to handle different traversal scenarios. You will categorize iterators into types like forward, bidirectional, and random access. And finally, you will understand how to create a simple custom iterator, an essential skill for designing iterable classes. We will also discuss common pitfalls to avoid while using iterators, so you can write safer and cleaner C++ code. So what exactly is an iterator? In simple terms, an iterator is a generalized pointer. It acts like a pointer in that you can move it forward or backward and dereference it to access elements. But unlike raw pointers, iterators are safe type and container aware, meaning they know how to work with STL containers. They provide a common interface that allows us to traverse elements without knowing the container's internal structure. Thanks to iterators, algorithms like sort, find, accumulate, and many more can work with any container uniformly, whether it's a vector, set, or map. They truly embody the power of abstraction in STL. STL classifies iterator into 5 categories, each offering different capabilities. Let's go and explore them. Input iterators. These can read data as we move forward through a container. You can think of them like reading from a file or stream. Output iterators. These are used to write data, for instance, writing to an output stream or inserting into a container. Forward iterators. These support multiple passes in the forward direction, useful in singly linked lists. Bidirectional iterators. These can move both forward and backward. Think of list and set. They support bidirectional iteration. Random access iterators, the most powerful. They support direct jumping, like moving ahead by 3 positions instantly. Containers like vector and dequeue support this. Understanding which type your container supports helps you choose the right algorithm and method for the job. Now let's explore constant iterators or const iterators. These iterators offer read-only access to the elements of a container. You can traverse using them, but you cannot modify the values they point to. This immutability is valuable in several scenarios. When working with functions that must not alter other container, when you want to guarantee safety in large collaborative code bases. In code, we use cbegin and cend instead of begin and end to get const iterators. This ensures your code won't compile if someone tries to modify an element within the loop. Const iterators enforce discipline. Sometimes we want to iterate in reverse order, from the end of a container to the beginning. STL offers a neat solution, reverse iterators. To use them, we call rbegin and rend on a container. For constant access, we use crbegin and crend. For instance, you can see this code. This prints the vector from the last element to the first. Reverse iterators come in handy in sorting, backtracking algorithms, or whenever the last elements have higher priority, like when implementing undo features or history stats. It's time to look at an example that uses all 3 major iterator value types, the regular, constant, and reverse. In this code snippet, the regular iterator iterates and updates the vector elements. The constant iterator ensures read-only access. The reverse iterator prints the modified values in reverse. By mixing and matching these iterator types based on your requirements, you gain both flexibility and safety in your code. Now it's time to take a step further into custom iterators. Why do we need them? Imagine you are creating a new data structure like a graph or matrix. To make it compatible with STL algorithms like for each or sort, your class needs to expose an iterator interface. Custom iterators provide that interface. They allow you to define how your object should be traversed. It's a powerful tool that elevates your C++ skills, especially if you ever work with non-STL data structures or build your own. Here's a simple example of a custom iterator embedded inside a class. We have a myContainer class with a nested iterator class. This iterator overloads key operators like not equal to plus plus and asterisk multiplied, allowing us to use it in a range-based for loop. We define begin and end to return instances of our custom iterator. This way our class becomes iterable, just like STL containers. This is a basic version, but it captures the core idea. In production, you would add bounds checking and possibly support for reverse iteration too. Let's go over a few common mistakes when working with iterators so you know what to avoid. Modifying with const iterator. You will get a compile error if you try changing elements. Use regular iterators when updates are required. Encourage use of AND in reverse iteration. If you use AND instead of RAND in reverse loops, the logic breaks. Dereferencing invalid iterators. This happens when you access an element after erasing it or from an empty container. Always validate your iterators. Avoiding these pitfalls will save you from undefined behavior and confusing bugs. To reinforce your understanding, try out these problems. Reverse print a vector using both for loops and reverse iterators. Create a matrix wrapper class and implement a custom row-wise iterator. Use reverse iterators with a map to print key value pairs in descending key order. Compare regular versus constant iterator usage and performance. These exercises will help you apply today's concepts and build deeper familiarity with iterator mechanics. Here's a fun mini challenge. Write a function called print backwards that takes a dequeue of strings and prints each element in reverse using a reverse iterator. This exercise checks your understanding of both containers and reverse traversal. Try implementing it after this lesson. It's a short but insightful. Let's wrap up. Today we have learned what iterators are and how they abstract traversal in STL. How to use constant iterators for safety and reverse iterators for backward traversal. The 5 categories of iterators based on their power. And how to write a basic custom iterator to make your classes STL compatible. You also reviewed pitfalls and practiced real problems. With iterators in your toolkit, you are now ready to work more efficiently with STL containers and algorithms. Great job today!